Welcome to Math 106, Chapter 0.3, the Algebra of Functions. We're going to start with a little bit of a discussion on profit, just very brief. We'll get into it a little bit more. And then we're going to go on to practicing combining functions and then composite functions. So first, it says in the near future, we'll be discussing more on profit. But for now, we can conclude that P of X is equal to R of X minus C of X. So therefore, profit is equal to revenue minus cost. So we have revenue here, and then we have your cost, and we're going to subtract the two. Now, revenue and cost each have their own equations. So they each have their own equations, and then when combined, we'll end up getting profit. So in the process of creating just a profit, it's called combining functions. We're going to take two functions and combine them together. Now we're going to be subtracting the cost one specific in order to get to the equation. So let's say we have two equations. Revenue, let's say, is 5x plus 1, and your cost is 2x. So in order to find your profit, we'll end up subtracting the two. So we'll take your revenue here. So we have 5x. I'm so sorry, I have some noise in the background. We have 5x plus 1. This is your revenue. We're going to subtract your cost, which your cost here is your 2x. Now you'll notice that I'm using parentheses. Parentheses are intentional, especially with subtraction. We want to make sure that we distribute your negative sign throughout the expression, meaning that if this was a binomial, so if we had plus 1 or minus 1 or whatever, we'll be doing it to the second term as well. So for us, it doesn't matter quite much. We have 5x plus 1 minus 2x. Now from here, when we want to create your profit, we now need to combine your like terms, meaning that we can combine 5x minus 2x to make 3x plus 1. And this would be your new profit equation. So this would be your end result, which again, you could create an equation for, or you could end up graphing now that you have the equation. Now that process of combining those functions is the main goal of the first part of the lecture. And then we'll talk about how to incorporate one function inside of another. We'll be using that process a lot throughout your calculus class when we try to deconstruct to figure out your derivatives. So it says we can add f of x plus g of x, subtract them, multiply them, and divide them, much like we did in the above. So let's take your two functions in example 1, and let's try to do all four. So let's first work on adding them. So we'll add f of x plus g of x. And when you're ready, you can pause the video and work through all of these when you're ready. So we're going to take f of x and we're going to add it to g of x. So we have 2x plus 4 plus, and I'm going to use parentheses here, 2x minus 6. We can then go ahead and combine 2x plus 4 plus 2x minus 6. This part you don't need to quite, this step isn't quite necessary if you already can kind of see it. For me, I'm going to require at the very minimum one step. So 2x plus 2x, 4x, 4 minus 6, that would give us negative 2. So our final product is 4x minus 2. Let's try it again. When we subtract the 2, we have f of x. And let's this time subtract g of x. Now keep in mind, it will produce a different outcome if we do the opposite, g of x minus f of x. So again, we take your f of x, 2x plus 4, and we're going to subtract g of x, 2x minus 6. And when we distribute, we're going to go throughout the expression, and all we have to do is change each sign. So we have 2x plus 4 minus 2x, and it was a negative 6. Now it's going to be a positive 6. And now we can go ahead and combine. We have 2x minus 2x. That gives us 0 x's. And then 4 plus 6, that'll give us 10. Again, that is just your final outcome. Again, this If we were to graph these, we could. This one would be the constant. I believe G is this color. I'm a huge fan of color if you can't tell. Now let's go ahead and multiply f of x times g of x. So we're trying to multiply 2x plus 4 times 2x minus 6. Now, when it's in this process, we are talking about foiling. If this is the first time you're foiling, we're just talking about taking your first two terms and multiplying them together. I don't like writing it like that. First, so you're getting to multiply your first two terms together. This is the f part. So 2x, and I'm going to do it slowly because it's our first time. 2x times 2x, you multiply your first coefficients, and then x times x, that gives us x squared, your two x's. And then we move on to the O. This is your outer terms. All of a sudden, I can't spell outer. Outer terms, so that you get to multiply the 2 on the outside. So that would make 2x. And I can just say plus 2x because this one is positive, times a negative 6. That will give us negative 12x. And then we have our inner term. We multiply these two on the inside. That's my I. So we can say plus 4 times 2x. Oops. To give us 8x. And then L is our last two terms. So plus 4 times negative 6, that's negative 24. Oops, and I left off an x. All right, so now all we have to do is combine your middle two terms. That would be these two, oops, these two in the middle. So we have 4x squared minus 4x minus 24. And this would be your final product. This is a skill that I think you are bringing into the class. So this hopefully is just a nice review. Let's go ahead and divide. We have f of x divided by g of x. So we have 2x plus 4 over 2x minus 6. Now our 2x's are not going to cancel each other out. They need to be the exact same when they are binomial. So a binomial is when there are two terms. A trinomial is when there are three. And then you could say polynomial for more than that if needed. Now, things will cancel. Now, we haven't quite learned this yet, but there is factoring. So we want to look at what each one has in common. So what do 2 and 4, we'll just look at your coefficients. What do they have in common? Well, they both have a 2. So let's break them up as if we had the 2. So 2 and 2. So if they both have this little 2 in common, we're going to factor out that 2. So on the outside, I'm going to write a 2. And then on the inside is whatever gets left over. Now, this is the 2 that got factored out. So in your first term, right, what got, we can cancel out this 2 because we factored it out. It's represented here. So we're left over with the 1 and the x. Plus, and then in your other term, right, we wrote this 4 as a 2 times a 2. Again, the orange one got factored out, so we're left with a 2. Let's do the same thing for the bottom. What do 2 and 6 have in common? Well, they both have a 2, so we can rewrite them both to represent 2. So again, they both have a 2 in common. So we can factor that 2 out. And again, once more, what got left behind? Well, of this term, right, this 2 is now represented as a 1 times a 2. The orange is that orange 2 here. So we are left with a 1x. So we got, again, a 1x. Then you have minus, and the 6 got rewritten as a 2 times 3. The orange we took out, so what's left over is the 3. And we have a -3 here because of the subtraction sign. Now these parentheses are not the exact same, so they can't cancel. The x's don't cancel, but you do have 2 of the same number on the outside. So we can go ahead and cancel those out. So the simplified version would be x plus 2 over x minus 3. Now this is what we're going to be capable of. I want to say in a few sections we'll talk about factoring here, but this is what I would expect your answer to be on the test. So this is your final product when done out. And you have your F here, your G here. Now let's try it again with example 2. Now example 2 is a little different because we have now rational exponents. So fractional functions. So before we freak out, keep in mind what we've done in the past or what you may have done in the past. So first, when we are asking to add and subtract fractions, can you just subtract 2 and the 7 and make, I don't know, a -5? No. What we have to do is make sure that these fractions are completely balanced. Now, do 2 and 7 have anything in common? No, right? So what we can do when there's nothing in common is that we can multiply each of your denominators to the other. So this 7 can multiply by a 2, and what you do to the bottom, you do to the top. And on the other side, this 2 can be multiplied by the 7. So we multiply by what's missing. Multiply denominator by each other, or what is missing. Common denominator. So first we want to get the common denominator. So down below, we both now have a 14. So now these are common denominators. Even better, they're the least common denominator. They're the smallest denominator possible. Now in the numerator, we have 7 and we have an 8. So we can go ahead and now subtract them to make a -1/14, 1/14, right? So that's how we can do it. Now for us, right, when we're trying to subtract g of x minus h of x, so 2 over x minus 3 over x minus 1, it's a binomial. So yes, this x is similar to this one, but this x is going to stand as a number, and we're going to take away 1 from it. So these, in fact, are not exactly the same. That's why I'm going to put these in parentheses to make us hesitate in order to just, subtract the 1 and then subtract. It makes no sense if you do that, okay? This denominator is different from this one. Even if you said, okay, well, x is equal to 3. Okay, 3 minus 1, well, that's 2. And then this is 3. Oh, very different, right? So think about these denominators as being very different to begin with. So same idea as what we have applied from before, right? Denominators are different. Therefore, we need the common denominator multiply by each other. And what I mean by what's missing is that if this was already factored, let's say this already had an x, and then this is x minus 1. This x represents this one right here because it's on the outside of that parentheses, meaning that it only is missing the x minus 1 to match. But for us, we have nothing in common, meaning that this one needs to be multiplied by an x. What you do to the bottom, you do to the top. And this one needs an x minus 1. So in your numerator, we should get 2 times x minus 1 minus 3 times x. And I suggest we put it all over your denominator, but if you wanted to, we could do it in parts like this, right? Now, we do not end up canceling here for the same fact that up above here, we didn't just cancel, right? Or cancel these, I would say. and make it 1/2. If you do, you go backwards. Same thing here. If you were to cancel these, you're left over with what you started. So we don't ever cancel. Instead, what we can do is keep forming them together. You make one common denominator. Previously, we just had a 14, right? The 14 came from the 7 times the 2. Ours, we're going to keep as the factored form as such. Now, in your numerator, we have this. So our next logical step is to clean up the numerator. So here, I can just say combine under one denominator. Now simplify the top, the numerator, meaning that we're going to have to distribute to x minus 2 minus 3x all over x minus 1. Keep this factored. Because if we're lucky, things can cancel in the future. So let's go and simplify. We're going to have negative x minus 2 all over x minus 1. Now, unfortunately, nothing will cancel. You could rewrite this because a lot of instructors don't like having a negative leading coefficient. You could factor out the negative and change your signs from above. Again, we'll talk about factoring in a few units. So if you're not ready for factoring, that's okay to leave your answer as such. Now let's talk about your domain. What would your domain be? Well, what values do you need to restrict? Keep in mind your numerator, unless it directly cancels with something in your denominator, which it's still going to matter for your domain, right? We can largely ignore this part and look at just the denominator. And that's why we want to keep it factored, is that in your denominator, we don't want to be equal to 0. Meaning that we can say either x is equal to 0 or x minus 1 is equal to 0. Do a little bit of the math. We can add the 1. So x is equal to 1 and x is equal to 0. These will cause issues if we were to put it back into your equation. It's going to cause an undefined response. So your numbers to avoid, so we want to exclude when x is equal to 0 and 1. So on your number line here, we're excluding at 0 and again at 1. Meaning that we can be any number that we'd like other than 0 and 1. So to write that in terms of an interval notation, your first chunk here, we're going from negative infinity to 0. And because we cannot be these values, we can't be infinity ever, we won't achieve it. And we're saying we want to exclude 0. So we're going to jump over 0, so using parentheses. Then our domain continues. We now have to do this second chunk. So we have union, any number from 0 to 1, excluding those two values. And again, union to now signify your third chunk from 1 to infinity. Now, I have lots of videos on this, so please search our YouTube page. A lot of 119 does that as well, just talking all about your domain, how it ends up being excluding that. I want to say that was in chapter 1.4 and 1.8, and again, all over chapter, I want to say that was like chapter 4 or chapter 5 when we talked about it again, but it's all over, and again in chapter 1.9 and 119. So please look at that. You could also go back a video where we talked about that domain as well. Now, how do you multiply these two fractions? Well, there's a couple different ways. So see if you can pause the video and start us off. One way is to multiply directly across. So 1 times 4 is just 1, 2 times 7 is 14. Now 14 and 4, they do have a 2 in common. So you could say that this is equal to 2 times 2 or 2 times 7, which means that the 2's are exactly alike so they can cancel, and this will make a 2 out of a 7. Now this is kind of unnecessary if you can remember, if I were to set it up one more time, that directly across, so if you're looking across, these 2 and the 4, they both have a 2 in common, meaning that you can rewrite the 4 to make up 2, meaning that this 2 and this 2 can cancel, meaning that your leftover bit is a 2 and the 7 over here. So if you were to rewrite it nice and clean, you just have 1 over 1 times 2 over 7, or just 2 over 7. So when it comes to multiplication, you can multiply directly across. You won't always be able to cancel common factors. That would be like that 2 that we got to cancel out. But if not, what you can do is just multiply directly across. So if we were asked to multiply g of x times h of x, we would multiply 2 over x times 3 over x minus 1. And again, I'll put these in parentheses. So when you multiply, you can multiply directly across because there's nothing that can cancel out immediately. There's no 2 down below. There's no x above. Instead, what we can do when we multiply is just make 6 and then x minus 1. Now, if we were asked to divide your fractions, let's say we had the same fractions as before, 1/2 and 4 over 7 like this. And if we needed to simplify, anytime that you are dividing, you're going to keep, change, flip, or keep it, switch it, flip it, this bottom one. So just keep the sign. So if it's already positive, it remains positive. If it's negative, it remains negative. You're going to change your operation. So instead of division, we're now going to multiply, and then you're going to flip the fraction. You're always flipping the bottom fraction, 7 over 4. And then again, because there's no common factors across, or across from it, you can just multiply top to top, bottom to bottom. Now let's talk about composite functions. So a composite function is to place one function inside of another. So think about how you evaluate functions by replacing your x with the number. But instead of a number, you're going to replace x with a full expression. So think about what we do if we said f of x is equal to 3x plus 1, right? And if we just said, okay, well, what happens if I replace x with a 2? Right? Well, what would happen is that all we're doing is that we're leaving a gap where x used to be. We're saying, okay, well, now it's going to become a 2. Okay, well, this is now 6 plus 1, which is equal to 7. And all we're going to do is just get slightly bigger. Let's just say 3x plus 1. Now let's say x is equal to 2, let's say 2a. Okay, well, f, there's an x, I'm going to leave a gap. There's an x, I'm going to leave a gap and use parentheses. I'm now going to replace it not with a number, but just with a different variable and a coefficient. Okay, so now this is 6a plus 1. And they're just going to get a little bit bigger each time. I won't go too crazy with these. Let's just say x is now equal to 2a plus 1. So f, again, leave a gap where the x used to be. Leave a gap. And then you just get to replace it to a plus 1. And now all that's different is that now that it's a binomial, or if it's bigger, all you're going to do is just multiply throughout that expression. 6a plus 3 plus the 1 from the outside. Okay, these two make 6a. This and this one make your 3. And then you have your plus 1. So this full thing is 6a plus 4. Right, so we're just going to get slightly bigger. Notice that we're used to this. We are definitely capable of that. And now we're taking it a step further. So now, if we're asked to make the composite function, there's two ways in order to read these. It says f of g of x. F of g of x. This just says, which is also the same as fog. You might have seen that in the past, fog. So this is just saying take g of x and put it inside f of x. So if we were to do exactly that, we're just saying, okay, f of g of x. And I like to rewrite it for a reason, and I'm going to encourage you guys to do so to start. So we have f of g of x here. So when I rewrite it, again, I'd like you guys to rewrite it. Well, what is g of x? Well, g of x is this whole thing right here. It is negative 5x minus 4. So we get to, just as we've done previously from evaluating, we get to slip it right inside f. Your f has this x on the inside. It used to be the square root of x plus 1. However, we said leave a gap where there's an x, and I'm going to do that one more time. I'm going to say I put the 1 over here. My x is now negative 5x minus 4. This used to be my x here, and I've replaced it with g. So now, underneath the square root, I have negative 5x minus 4 plus 1. Cleaning it up, I have negative 5 minus, negative 5x minus 3. So we take one function, we took this function, we took g of x, and we put it inside f of x. Now let's have you guys try it again. Let's have you guys find g of f of x, or goff. This just says g of f of x. Put f of x inside g of x. Whatever's on the inside is going to go on the inside, if that makes sense. Whatever's on the second one is the one going on the inside. They will produce different results the majority of the time. It's not often that they make the exact same function. So again, I would write it exactly how you're seeing it. So we went from g of f of x is equal to, okay, take g, and now we're going to take f, which I think f, I've been using this color, and I'm going to put it on the inside. The square root of x plus 1. Now I'm going to put f of x on the inside of g. So see if you can pause the video and try that out. So g used to be negative 5, x, I'm going to leave a gap, minus 4. That gap, I'm going to put the square root of x plus 1, and that is where my x value goes. So we have negative 5, the square root of x plus 1, minus 4. And again, that is your end result. There's not much else you can do with it, as long as it makes sense to logical thought down below. That should be it. Let's have you do it once more with the next page. It says find f of g of x and g of f of x. So pause the video and see what you can come up with. So we have f of g of x, which is equal to, okay, well, f of x is on the outside, and g of x we said is x minus 5. We have x here squared, so leave a gap, square it, plus 3, it's x, so leave a gap, plus 1. Now, in those gaps, we get to replace it with your g being x minus 5. So this is where your g is. So x minus 5, x minus 5. Then we have x minus 5 squared. So x minus 5 squared is not x squared minus 5 squared. That is not correct. Instead, just like x squared is really x times x minus 5 squared is really x minus 5 times x minus 5. So it's 2 of them. So we're going to write 2 of them out. Plus, and then if you want, you can distribute, start to simplify. X minus 15 plus 1. Oops, I don't know why I kept those parentheses. There we go. Now you can start to FOIL, right? The first 2 terms, x times x makes x squared. Then your inner terms, or your outer terms, that makes negative 5x. Your inner terms, negative 5x. And your last 2 terms, positive 25. They're positive because they're both negative 5. We have plus 3x minus 14. I'm just going to do that little addition there. And now we can go ahead and simplify. We have negative 10x plus 25 plus 3x minus 14. And now we combine once more if you can, or you can do it all at once, just in case. And there you go. So f of g of x comes out to x squared minus 7x plus 11. Let's have you try it again with g of f of x. So this one is g, and we're going to take this trinomial and put it on the inside. So this is my trinomial f of x. Okay, I have x here, and I have minus 5, and I'm going to replace all of my x's with x squared plus 3x plus 1. So you get x squared plus 3x plus 1 minus 5, a little redundant on that step, minus 4. So that should be your end product. Now, the reason why this is beneficial is that we're going to be seeing in the future derivatives when it's the chain rule. So this is really helpful on recognizing what functions on the inside and then what's on the outside and how to kind of deconstruct them. All right, so that is our video. The next video, if you need a little bit more help on the composite function, definitely take a look. If you need a little bit more on rational expressions, how to add, subtract, multiply, divide, definitely take a look at our 119, chapter 1, where we talk about those rationals, especially your domain on those. That's around chapter 1.4, again in 1.9 or so, that sort of area. And then when it comes to composite functions in 119, because a lot of these videos are repetitive, that comes into play in chapter 4.3, I believe. All right, and that is the end of our video.